to our objective 2.9 sample problems. Objective 2.9 says I can solve real-world problems using my knowledge of right triangle. So let's do some of that. Let's solve some application problems with some right triangle trig. All right. Letter A, the top of the Matagorda Island Lighthouse in Texas is about 90 feet from above sea level. The angle of elevation from a fishing boat to the top of the lighthouse is 10 degrees. After the boat drifts for half an hour, the angle is 15 to the nearest foot. How much closer has the boat moved from the lighthouse? Oh, I love this problem. I love it. Okay, so we have lighthouse that is 90 feet tall. And we have a boat that originally starts with a degree of 10. And we want to figure out this distance, how far away it is from shore. Okay, so let's put together what we know here. This would be my hypotenuse. Don't really care about that. This would be my opposite. This is what we want to find our distance, which would be our adjacent side to this angle here. Okay, so what equation are we going to use? Tangent. So we'd say the tangent of 10 degrees equals my opposite, 90, over my adjacent, the distance I'm trying to find. That means that the distance is 90 divided by the tangent of 10. Let's put that into our calculator here. So we'd say 90 divided by the tangent of 10, close parentheses, and we get 510.42. So 510.42. Okay, now, so that's the first one. After half an hour, the angle of elevation has increased to 15%. So let's see how far away it is now. So we have this new guy. It's 15 degrees now. The lighthouse is still 90 feet above sea level. And we're still trying to find our now new distance. So same equation, only we're just switching it up so that it'd be the tangent of 15 is 90 over d, which means that d equals 90 divided by the tangent of 15. 90 divided by the tangent of 15, yes, 335.88. So notice now, it asks, to the nearest foot, how much closer has the boat moved from the lighthouse? Weirdly worded question, but we'll take it. So we want to find the difference between these two. So we do 510.42 minus 335.88, and we get 174.54 feet. Over those 30 minutes, it is 174.54 feet closer to the shore. Fantastic. All right. Letter B, a passenger in an airplane sees two towns directly to the left of the plane. If his angle of depression, all right, so another vocab word, angle of depression to the first town is 25 degrees. His angle of depression to the second town is 15 degrees. All right, if the airplane is 25,000 feet above the ground, how far apart are the two towns? Oh, cool. Okay, so let's make a picture here. So we have an airplane that is flying at 25,000 feet. And remember our angle of depression, they tell us that this angle is 25 degrees for one. And in the other, I'm going to go ahead and draw them both right now. So we have 25,000 here. And this angle of depression is 15 degrees for the other. Okay. So what we're going to do is similar to our last problem. We're going to find the distance away the town is from the plane, and then we'll do the subtraction between the two to figure out how far apart the towns are from themselves. So with that being said, there's some math we have to do first here. So we know that this is a right angle here. We have a right angle there. However, we know that this is 25, so we can do 90 minus 25, and that'll tell us that this angle here is 65 degrees. Okay. All right. Let's use that angle in our problem. That tells us the other one then would be 75 degrees. So those are the angles we're actually going to use in this trig. So let's think about, we have our opposite side and our adjacent side. So that means that we would use tangent. We'd say the tangent of 65 is our opposite. We don't know over our adjacent, 25,000. So that means D will equal 25,000 times the tangent of 65. Let's do that on a calculator. 2, 5, 1, 2, 3 zeros times the tangent of 65. And we get 607.7. And this is feet. Wow. Okay. So that's how far away the plane is from being directly over the first town. Now the second town has the 15 degrees angle, so that means the angle in the triangle would be 75. Same equation to set up here. So we'd say that D equals 25,000 times the tangent of 75 this time. So I'm just going to do a copy paste here and 75. There we go. Oh, wow, look at that one. So 93,301.27 feet. So that we will subtract then the 53,612.67, and we will learn that the towns are 39,688.60 feet apart. Awesome. Gosh, great problems. I love those two problems. All right. Last one here, letter C. You are standing 45 meters from the base of the Empire State Building. You estimate that your angle of elevation to the 86th floor is 82 degrees. If the total height of the building is another 123 meters above the 86th floor, what's the approximate height of the building? Okay, definite picture time. So we are standing at the edge. We're standing 45 meters away. We estimate an angle of elevation of 82 degrees. And there's an additional 123 meters above. So we have this additional height of 123 meters. Obviously, picture not drawn to scale. Remember, it doesn't need to be. So in order to find the total height of the building, we need to find this distance, and it would be x plus 123, right? That would be our total height. So let's figure out what x is. So this is opposite, adjacent. Again, we're using tangent. So we'd say the tangent of 82 equals my opposite over my adjacent, 45. So that means x will equal 45 times the tangent of 82. 45 tangent of 82. And we get 320.19. And then we're going to add to that the 123. When I do that, I would get 443.19 meters. And that, my friends, would be how tall the Empire State Building, or at least our estimation for how tall it would be. Fantastic. All right, hopefully we're feeling confident with this trig, using trig to solve some right triangles in the real world. This is Mr. Carter signing off for the final time for Unit 2. I'll see you at Unit 3. Get going on those practice problems. We'll see you next time.